Find the approximate value of the square root of 2 minus 1.05 squared. The first thing to do is to identify the x value that is being operated on. That will be the decimal number, x equals 1.05. Second thing to do is to identify the function that is operating on the x value and call it f of x. Here, we have the square root of 2 minus 1.05 squared, with 1.05 being the x, so f of x will be 2 minus x squared under a square root. The third thing to do is to identify a value a near the x value of 1.05 that can be easily evaluated in this function f of x. 1 is near 1.05, and it's easy to square, and if you subtract it from 2 after squaring it, it'll give us a 1, which is a perfect square under the square root, so a will definitely be a 1 here. We can now find the linear approximation to f of x, which requires f of x as well as its derivative f prime of x. Before we take the derivative, we can rewrite the square root as a fractional exponent. It's to the first power, second root 1/2 power. The derivative f prime of x will therefore be a power rule. Bring the power down, leave the inside alone, 2 minus x squared. Subtract 1 from the power, I will call that 2/2, and then multiply by the derivative of the inside to complete the chain rule. The derivative of a by 2 is 0. The derivative of negative x squared is negative 2x. The negative 2 can move out front with the 1/2. Negative 2 times 1/2 is a negative 1. And the x can move out front with that. The 1's implied, so we can write that as negative x. And then 2 minus x squared will be raised to the 1 minus 2, which is negative 1 over the common denominator of 2. Since we have a negative exponent, we will want to rewrite this by moving it to the denominator, giving negative x staying in the numerator, 2 minus x squared to the positive 1/2 in the denominator. Positive 1/2 means square root to the first power, so we can write this as the square root of 2 minus x squared. We can now evaluate f of x and f prime of x at the a value of 1. F of 1 will be the square root of 2 minus 1 squared, which is the square root of 2 minus, this is 1 squared and then the minus, so you square the 1 only, which becomes a 1, and then we subtract it from a 2. So the square root of 2 minus 1, which will be the square root of 1, which is equal to 1. And the derivative, f prime of x, evaluated at the a value, f prime of 1, will be negative 1 over the square root of 2 minus 1 squared, which is negative 1 over the square root of 2 minus 1 squared is a 1. Negative 1 over the square root of 1. The square root of 1 is a 1, so we have negative 1 over 1, which equals to negative 1. The formula for the linear approximation is L of x equals f of a plus f prime of a times x minus a. In this problem, a is a 1, so this will be f of 1 plus f prime of 1 times x minus 1. We have values for f of 1 and f prime of 1 that can be put into place. So the linear approximation will equal to f of 1 is a 1 plus f prime of 1, which is a negative 1, plus a negative 1 is equivalent to minus a 1 times x minus 1. F of 1.05 can be approximated by L of 1.05. F of 1.05 will be f of x replaced with 1.05, so that comes out to the square root of 2 minus 1.05 squared. And that's approximately equal to L of 1.05, which is L of x replaced with 1.05 in for the x, which will give 1 minus 1 times 1.05 minus 1, which is equal to 1 minus 1 times 1.05 minus 1 is 0.05, which equals to 1 minus 1 times 0.05 is 0.05. So that the square root of 2 minus 1.05 squared is approximately equal to 1 minus 0.05, which comes out to 0.95. And there's the approximate value of the square root of 2 minus 1.05 squared.